Tuition Mobile, quality e-learning experience on the go.
Hello and welcome back to the class. Our topic today is captioned the cosine rule. Okay, and we'll go ahead to derive the formula. But before we derive the formula, let me say this, that the cosine rule is used when you have two sides and the angle between them, okay, between them given. All right, or when you are given the three sides, okay. All right, we shall derive this formula using a triangle. Okay, we shall derive this formula for the cosine rule using a triangle, and then we'll have this triangle. Okay, and then at this point you have A, we have B here, and then we'll have C. And then if there is another triangle enclosed into this, and then we have this from this side to this side to be denoted as X, and then we have this side to be equal to C, and then here there is a line parallel to AC as D, and then the whole of this side as A. Okay, so we will go ahead to note that CD line is equal to A minus X. Okay, and so we'll try to find the relationship between the two triangles as given above. And so in triangle A, B and D, okay, it implies that AD squared, being the line of demarcation, is equal to AB squared in triangle ABD is equal to AB squared minus BD squared. Okay, and so we can as well write to be equal to AB squared is equal to C squared, and then BD squared is equal to X squared, right? And then in triangle ACD, this implies that AD squared, okay, will be equal to AC squared minus CD squared. Okay, you have AC squared minus CD squared, which is also equal to AC is equal to B, because that's the side fixing B, okay, and B squared, and then CD is equal to X minus A, I guess. Sorry, CD is equal to A minus X. Here we've indicated it, okay, A minus X, okay, all squared. All right, so we determine the relationship between the two triangles, and so since we want to check whether they are equal, this implies that C squared minus X squared is equal to B squared minus AX, B squared minus A minus X all squared. Okay, so this gives us a C squared minus X squared is equal to B squared minus, expanding this bracket, we'll have A squared and then minus 2AX and plus X squared 2. Okay, so we have that C squared minus X squared is equal to B squared minus A squared, okay, and plus 2AX minus X squared. Okay, and so minus X squared and minus x squared can take care of themselves, and then we'll have c squared is equal to b squared minus a squared plus 2ax. Okay, all right, but we can rearrange this, and so we have as follows, that b squared minus a squared plus 2ax is equal to c. But if we want to find x, the value of x, how do we find the value of x from the triangle? We have that x from this triangle and x and c, x relative to the side c. We have that cos b can work for that, and so we have that cos b is equal to x over c, so that x will be equal to c cos b. All right, from your sine rule, from your trigonometries, you will get this. So we can replace x as c cos b. C squared is equal to b squared minus a squared plus 2, and then cos c cos b. Okay, all right, so you can say that c squared is equal to b squared minus a squared minus plus 2ac cos of b. Okay, so this gives us our Pythagoras theorem, the cosine rule rather. You know, we've been so conversant with Pythagoras, and we've always been applying it, so it's not a surprise. I keep saying it. And so we have from this part that you can still find cos b being the angle that maybe when you are looking for an angle, okay, you can make cos b the subject of formula. Okay, and that implies that you can simply say that c squared take over all other parts of the equation to one side, so you can make cos b the subject of formula. This becomes minus b squared. It crosses an equality sign, and this becomes a squared, okay, to be equal to 2ac cos b, so that therefore cos b will be equal to c squared minus b squared plus a squared, all divided by cos b, or divided by 2ac. all right, I think we don't make the mistake again. So we have cos b to be equal to c squared and minus b squared plus a squared all over 2ac. All right, and I want to give you a little secret from the formula we've derived, okay, and I believe it will help you so real. Now look at the formula for the cosine rule. You have to find out that if you are looking for if the missing angle is cos a, okay, now look at what happens. Okay, every other side becomes positive apart from a. Okay, that means side c will be positive, side b will be positive, but side a will be negative. Okay, and 2 will be the multiple of the two sides excluding a, and so you have the two sides c and b excluding a. Okay, I hope this works for you too. And then it means that cos c will be equal to cos c will be negative. Okay, c will be negative, and then a will be positive, and then b will be positive. Okay, and so you have the denominators to be the two positive sides ab. Okay, I just believe this works for you. And then you can as well use this to get your mixing you can as well use this to get missing sides just by trying to invert the formula back, assuming cos c over 1, because everything is over 1. And so this means that we have that minus c squared plus a squared plus b squared will be equal to 2ab multiplying cos c. All right, and so to continue this computation, we have to make C the subject of formula by crossing over the rest to the other side of the equation. Okay, assuming C is the side we are looking for, and so trying to cross the rest over to the other side, you have minus C squared to be equal to minus A squared minus B squared, and then 2AB cos C. Alright, this is plus 2AB cos C, and so you can switch this to back to the normal method we previously had, and then we have this to be equal to, when you multiply out sides by positive, you have C squared is equal to A squared plus B squared, okay, plus 2AB cos C. Alright, and the same thing happens to the first one, assuming we are given cos A, using our formula that cos A would be equal to B squared plus C squared minus A squared, okay, all over B squared, sorry, all over BC cos all over BC, sorry, not cos. Okay, so we're only saying that the two sides that are positive will multiply, so that BC cos A will be equal to B squared plus C squared minus A squared, and so subtracting BC cos A from both sides, we have that 0 is equal to B squared plus C squared minus A squared, and then minus BC cos A. Okay, and then the next thing we have to do is to carry over the odd fraction here, which is A squared, to the other side of the equation. If this becomes A squared is equal to B squared plus C squared minus 2BC cos A. Alright, and so this should be minus sign, please. This is minus 2A because C. Alright, fine. I think that's what we'll have there. Okay, fine, good. And so this is the formula we need to do our computations on our sine rule. Okay, so all we are saying is that if you are looking for the side A squared, okay, then it means you have the other sides positive, okay, and then minus 2BC cos of A. Alright, and then if you're looking for the side B squared, you have A squared plus C squared minus 2AC cos of B, and then you're looking for C squared, you have A squared plus B squared minus 2AB cos of C. Alright, and the same thing applies to if you want to find the mixing angle cos A. You have to denote your formula as cos A equal to B squared plus C squared minus A squared all over 2 the two positive side BC, and then cos of the missing side B is given as B squared. B squared will be negative, and so the rest will be positive A squared C squared minus B squared all over 2 AC, the two positive sides, and then the cos of C, okay, will be equal to A squared plus B squared minus C squared all over 2 A and B. And so these are the formulas we need to determine both the missing sides and the angles. Alright, okay, for both the missing sides and the angles. So we'll go directly into applying these formulas, wow, and see how they work out. And so we just have to take two examples. Example one, you're told to find the angles of the triangle. Find the angles of the triangle with the following dimension. Okay, A is equal to 12 cm, B is equal to 11 cm, and the C is equal to 9 cm. Alright, so if this were to be our triangle, all we have been asked to do is to find the angles around the triangle A, B, and C, and then you tell the small letter B is equal to 11 cm, and small letter C is equal to 9 cm, and small letter A is equal to 12 cm. Alright, and then we don't know the angles, if I should say the angles B, and we don't know the angles C, and then we don't know the angles capital A around this triangle. So how do we find them? Alright, remember that when we are looking for angles, okay, we can find the angles using any of the three equations here from 4 to 6. Sorry, alright, this should be 6 VI, not IV. Okay, and so if at all we want to find cos B, we want to find the angle B, or should we start with A because it is the first alphabet? Okay, let's start with A. Cos A gives us that it is equal to B squared. B and C become positive while A becomes negative, multiplied by 2 times B and C, the two positive numbers, okay, which is equal to B squared there is 11 squared plus C squared there is 9 squared minus A squared there is 12 squared, all over 2 times B there is 11, and then C is equal to 9. Alright, and so we have that 11 squared is 121, and then 9 squared is 81, and so we have this to be equal to 121 plus 81 minus 144. Okay, and then 2 times 11 is 22, and 22 times 9 gives us 198. Okay, and so this gives us that 121 plus 81 minus 144 gives 58 over 198. So we have that cos A is equal to 58 over 198. So when you divide this, okay, you have that cos A is equal to 0.2929. Alright, and so to find A we have to take cos inverse of 0.2929, and all you have to do is to press shift on your calculator plus cos. Okay, and then when you do that, you have shift on your calculator and cos, and so you have A inverse to be equal to 72.97 degrees, okay, which is approximately equal to 73 degrees. And so we're saying that angle A is 73 degrees. Okay, and so we go ahead to determine angle B, maybe because that's the second letter of the alphabet. Not really, you can determine any angle, I'm just making fun of it. And so angle B is equal to A squared plus C squared, A squared plus C squared, and minus B squared, all divided by 2 times the two positive numbers A and C. Alright, okay, this is as good as saying A squared from previous example is 12 squared. Alright, and B squared, B is 11, A 12, B 11, C is 9, A 12 squared plus 9 squared minus 11 squared, all over 2 times 12 times 9. Alright, and so this computation 12 squared, okay, this computation 12 squared plus 9 squared minus 11 squared, okay, will give 104. Alright, and then 2 times 12 times 9 is equal to 216. Okay, 104 divided by 216 will give us that cos B is equal to 0.4815, and so that B will be equal to cos inverse of 0.4815. okay, and then when we take shift cos of that, we'll have that to be equal to 61.21 degrees, which is approximately equal to 61 degrees. So we go back and fix B to be equal to 61 degrees. And so to find C is very simple now, since we have 61 and we have 73, and the total angle in a triangle is 180. Therefore C will be equal to 180 minus 61 and minus 73. okay, alright, minus 61 minus 73, and so we have 180 minus 61 and minus 73 to give us 46. So therefore C is equal to 46 degree. You can as well use the relationship there to continue solving, and you see that you know when you are correct, because when the sides are small, the smaller the size, the smaller the angle, the bigger the side, the bigger the angle, and then you can see it appear on the triangle. And so there are two approaches to finding C. Or you can find C by saying cos of C to be equal to A squared plus B squared minus C squared all over 2A and B. okay, where we have that A is equal to 12, B 11, and C is 9. So A is equal to 12 squared, 11 squared minus 9 squared all over 2 times 12 times 11. okay, and so we have this to be equal to 12 squared plus 11 squared. okay, and then when you subtract 9 squared, you have 184. Do that carefully, want to save time. And so you have 2 times 12 times 11, and so that gives us 264. alright, and then when we divide out, we have the outcome to be equal to 0 point. Therefore we can say cos C is equal to 0.6970, and so C is equal to cos inverse of 0.6970. and so when we take cos inverse of this, okay, we have it to be equal to 45.82, which is approximately equal to 46 degrees. alright, and so that gives us the angle with that side. We'll take, alright, our second example is taken as follows. If you're given that in a triangle, example 2, you're given the diagonals, the sides of a triangle as follows. okay, the size of the triangle are as follows: that A is equal to 7.2, and then capital A is equal to 72 degrees, and B is equal to C. okay, and then we are told to find the missing sides of the triangle. okay, so assuming this is our triangle, okay, and then you're told we have A, B, C, A, B, and C. alright, solution. okay, solution 2. And so you're told that side A is equal to 7.2, and side B, angle A, is 72 degrees. Now you should know that if B is equal to C, therefore angle B should be equal to angle C. And so if B is equal to C, the angles have to be the same too. Alright, and so we are told that we're just given a, alright, so if the angles are the same, I think all we have to do is to subtract 180 from 72 and then divide by 2 to find their two angles. Alright, so you have 180 minus 72. Okay, once you subtract this angle, you have 108, and since angle B and C are equal, they will share 108 into 2, so that angle B will be equal to 54 degrees, and then angle C2 will be equal to 54 degrees. And so we have angle B 54, they are equal, and then angle C 54 degrees too. And so this helps us simplify the working a bit. And so on the next line, we'll be talking of how to find sides AB, which is equal to C, and side AC, which is equal to small letter b. And so therefore we define C squared to be equal to A squared plus B squared, alright, minus 2AB cos of C. Okay, and so we continue where C squared is equal to A squared B squared, and then can this actually work? We cannot use the Pythagoras theorem here. Sorry, we cannot use the cosine rule here because of the fact that we do not have two sides. Okay, and but we have three angles, but we don't have two sides. So the condition states that two sides, one angle, or two sides or three sides in a whole, but we just have one side. The sides are not up to 2. So we can resolve to do this by using our sine rule. The sine rule can work out here where you have a side, an angle, and some other angles here. And so for the sine rule, we have that sine A over A, okay, is equal to sine B over B. Alright, so where sine A is equal to sine of 72, sine of 72 over 7.2, okay, is equal to sine B. The sine B is equal to sine of 54. Alright, sine of 54 degrees all over B. Note that B will be equal to C because both angles are equal, so therefore their sides will be equal. So therefore we have that B sine 72 is equal to 7.2 sine 54. Alright, let's do this quickly. And so we have that 7.2 sine 54 is equal to 5.8249. Okay, so that B will be equal to 5.8249 divided by sine 72. Okay, alright, so that B will be equal to 6.1246, okay, which is approximately equal to 6. So therefore B is equal to 6 and C is also equal to 6, and C is also equal to 6. Alright, so this gives us the missing side, and we have that B is equal to 6 and then C is equal to 6. So I think you should note that two sides that are equal will have equal angles too. We shall end the class here. Do have a nice day.